Alright, welcome back, ladies and gentlemen. We're looking at 5/4 or 5/5 day 2. Now we're going to do some basic problem solving with the formulas we had in the previous lesson. So we're going to solve problems using angle sum, angle difference, and double angle formulas. Okay. Here's the assignment. No big shock, but here we go. Alright, verifying identities. Alright, now with these new formulas, we have some basically more tools we can use for verifying different identities. And really, this is just an exercise in practicing with the formulas, getting used to them, making sure you have them memorized real well, and can use them in the appropriate time. Alright, so anyway, so I've got sine of pi over 2 plus x equals cosine. Well, definitely I think the left side looks like a little more complicated, so that's the one I'm going to mess with. Okay, and then the sine formula. Alright, well, sine is that good mathlete cheer kind of sounding thing. Sine, cosine, cosine, sine. 3.14149. Anyway, so we've got sine of pi over 2, so sine, cosine. So sine of the first times cosine of the second, and then sine keeps the same sign. And then it's cosine sine of the angles in that order, so pi over 2 first, and then the sine x. And again, in theory, I'll eventually turn this thing into cosine. Alright, well, sine of pi over 2, again, knowing your unit circle values like you're supposed to. Alright, sine of pi over 2, well, that's right about there, so the y-coordinate is 1, so basically that guy becomes a 1. Cosine x can't do much with, because I don't know what x is. And then cosine of pi, well, same location, but cosine works out to be 0 right there, so that's sine of x. And of course, 1 times cosine is simply cosine. Alright, 0 times sine basically cancels itself out, so there's nothing left over there, so now we have cosine equals cosine. We did get the desired result, so woohoo! Everybody's excited. And there's our whole entire problem. Fantabulous. Alright, let's move on to some other stuff. Alright, I can also ask you to simplify expressions based on these formulas, and then one little thing the book adds on here is confirming with the graph. And, graphs are very powerful tools, especially if it works out to be something you can recognize. Granted, we've done some solving by graphing where we have some really weird looking equations, so it's tough to tell what those things are. But realistically, if I graph cosine of pi minus x, I get a graph that looks a lot like this, which, hey, that looks like cosine kind of, but it looks like it's flipped upside down, so it looks like negative cosine. That's supposed to be a cosine right there. So that looks like negative cosine. So basically it just gives me something to shoot for as I'm doing this, as opposed to the verification where we're pretty much told what we're supposed to be shooting for. This kind of just lets me know what I probably will run into as I do this. And if I don't run into that, I go, okay, well, check my work. But okay, anyway, using the cosine formula, cosine pi minus x. Alright, so for cosine, I'm going to do cosine of the first angle times the cosine of the second angle. And then I want to use the opposite sign of what I see right there. And then sine sine. So sine of pi, sine of x. And again, we've got to resort to knowing our unit circle stuff, so I'll just put this down here because that's where I have space. Okay, pi is over here. Alright, so cosine of pi, well, x coordinate over there is negative 1, so that's cosine x. Plus sine of pi, well, that's 0, sine of x. And very similar to the last problem right here, this negative goes on the cosine, but this is more what's similar to the last problem, that 0 times something else cancels out, and we're just left with the negative cosine x, which again is verified there by the graph. Alright, so again, graphing is a powerful tool. It'll let me know that I was right, and there you go. Alrighty, now, again, these formulas allow us to solve equations that were previously a lot nastier to work with. Right now I've got a 0 to 2 pi sort of interval, so basically, again, none of that n pi stuff. So once I get my equations broken down, I'll just simply look at one unit circle worth and figure out my various angle measures off of that. Alright, so here we go. Now this one's a little bit icky, but here it is. Alright, so sine with a subtraction right here lets me break it into sine x cosine pi over 6. Okay, and then again I'm going to keep the same sign for now. And then cosine x times sine of pi over 6. Okay, I'm trying to write small here. Okay, then I get a minus, and for some folks probably a good idea to throw down a parenthesis right there. Alright, sine of x cosine pi over 6. Okay, now it's a plus right there. So it's a plus, although eventually I'll distribute a negative sign and change that, but for now, let's leave it where it is. And now we've got cosine of x, cosine, sine, pi over 6. I was just doing that to make sure you're paying attention. Alright, equals 1/2. Okay, as promised, I'm going to distribute a negative, and if we're made to do so, I've got some pi over 6 values that I'll be able to mess with. So again, pi over 6 puts us about right there. So since I've got a 1/2 for sine and a √3/2 for cosine, I'll just make those replacements wherever they come up. So here we go. So sine of x, nothing I can do there. Again, cosine of pi/6 is going to be √3/2 minus cosine x, and then the sine of pi/6 is 1/2. And I get my distributing a negative sign along the whole thing. So sine, again, cosine of pi/6 is still going to be a √3/2. Oops, there's an x in there. Okay, again, maybe throw that in parentheses, looks a little nicer that way. Alright, but then negative distributes here, it's a negative, and now I've got cosine x, and then again, sine of pi/6 is still 1/2, and that equals 1/2. Alright, good news is we have a little bit of mess we can clean up, because now the sine of x times √3/2, and then the sine of x times √3/2, one's positive, one negative, so those guys are going to go bye-bye just wonderfully. Alright, so I've got a negative cosine x times 1/2 and negative cosine x times 1/2. Okay, and for those of you fraction impaired, here's what I'm going to do for you. Negative 1/2 cosine x minus 1/2 cosine x equals 1/2. Alright, well, if I have a negative 1/2 and a negative 1/2, that gives me a negative 1, and that times cosine equals 1/2. Okay, I'll divide off the negative 1 and get cosine x equals negative 1/2. And I've got some very, very heavy unit circle values for that. So I can just draw in a quick value again, and I'm going for 0 to 2 pi. So where's cosine going to be 1/2, negative 1/2 that is. I'm going to be up to the left half of the graph. And again, out of the √3 and the √3/2 and the 1/2 rather, you do have simply the small side being the x, which is the 1/2. So there's our two angle measures. So basically x is going to be that 2 pi/3. Okay, and then around here it's 4 pi/3. And there's your answer. I just kind of like that one because you start with nothing but sines and you end up working with cosine by the end of it. But anyway, that's how you handle it. Biggest thing is, use the formulas, let the formulas kind of work, and a lot of times things will kind of sort themselves out as long as you handle things properly. Alrighty, now we've got another one involving a double angle formula, the big obvious thing. Double angles, you got the 2x right there. Again, for those of you with a really sloppy handwriting, be careful about sine squared x versus sine 2x. It's easy to mess those two up if you're sloppy about your writing. But anyway, here we go. This is obviously a 2x right here, or at least I hope it's obvious. Alright, but again, same basic thing is, well, you know what, before you do any substitution of the formula, it's hard to say whether or not anything productive is happening or not. So I'm going to take my sine 2x formula, so I'm going to replace it with 2 sine x cosine x. Okay, that's pretty nice. Plus cosine x equals 0. Okay, and then again I've got this common factor of cosine. So I'm going to take out cosine x, and then I'll be left with 2 sine x plus 1 equals 0. Okay, now hopefully once there you see that and you go, oh look, factors. So just set each one independently equal to 0. Cosine x equals 0. 2 sine x plus 1 equals 0. Whoops, that's an equal sign there. Alrighty. Okay, well, again, thinking unit circle stuff, let's put it down here, and I am still under the directions of 0 to 2 pi. So anyway here, cosine 0, again I want my x to be 0, and that's going to happen at the top of the circle and at the very bottom of the circle. And then 2 sine x equals, well, let me just get to where my brain is. Sine x equals negative 1/2, so negative 1/2 for sine. Okay, so if I'm negative, I'm in the bottom half of the graph, and at 1/2 it's going to put me at the pi/6 variance basically. Alright, so again, not a big deal what order these solutions come in, so I'll just kind of do the cosine ones first and then the sine ones second. But I've got pi/2 gave me 0, and then so did 3 pi/2. Okay, and then over here I've got a 7 pi/6, and then my 11 pi/6. Let's see if I can make that into a pi without screwing up. There we go, cool, beautiful. Alright, so 4 nice solutions for that one. Alright, of course, you just got to play around with it to kind of learn the ins and outs and make your own mistakes and then figure out how to fix them. But there you go. Any questions, obviously, ask me in class. See you then.